Hi, I'm Kai from Cambridge, and the presentation I'm giving today is urban microclimatic diversity and thermal comfort. Do variation in sun and wind conditions correlate with pet grades? One of the global climate challenges we are facing at present is to deal with thermal extreme weathers. Urban heat islands might result in serious indoor health-related risks in longer term. As ongoing quarantine measures have been taken in many places during the global pandemic, we desire more opportunities to go out for fresh airs in the cities. Here, outdoor thermal comfort becomes one of the urban challenges that we need to pay attention to. We need to understand the diversity of urban microclimate. In our research, this is reflected on which urban form could provide adequate sun and shade for people. Based on our findings, urban designers will be informed of the significant spatial impact on diversity of urban microclimates, which can be effectively controlled for mitigating discomfort and enriching thermal experience as well at early stage of design. In order to relate the microclimatic diversity with some classic thermal comfort theories, such as thermal adaptation theory and thermal anesthesia theory, we have found a research gap regarding the trade-off between neutrality and diversity. On the left, neutrality is always targeted to reduce discomfort on a strong or extreme thermal stress. On the right, this diversity could help to enhance our perceived control with a variation of environmental stimuli that induce the thermal pleasure. In this study, we try to decode the relationship between neutrality and diversity and to explore whether they are a pair of conflict or harmony. Well then, how to measure this pair of thermal attributes? A majority of outdoor thermal comfort studies have taken sensation scales, such as predicted mean volt PMV, physiological equivalent temperature PET, and universal thermoclimatic index UTCI. Here we've chosen PET since it's graded by 9 thermal stress levels. We've also cited the formula to calculate the gross diversity and wind diversity from recent work comparing urban geometry and thermal diversity. These diversity matrix would help to gain more insight on the balance between neutrality and diversity. So moving on to the research questions. Firstly, we are curious about dynamics in PET and the gross diversity. And secondly, we wonder how much spatial variation of PET and gross diversity are progressing on seasonal and diurnal basis. And finally, we attempt to correlate them by all pixel approximated from urban 3D models. So what's the feasible correlating methods? Here shows 3 study areas at theatre districts in London, Paris, and Vienna. These are all known as highly walkable environments, sharing almost the same pavement density, while we also should notice other distinct spatial characteristics, such as building density, coverage, and the amount and distribution of green spaces. The tools that we have employed for dealing with urban microclimate data are EnviMet and Grasshopper plugins in 3D Rhino software. For the first finding, we try to map out the spatial variation of PET and gross diversity. And for the second, these 2 average values were going to be compared on time series, diurnally and seasonally. In terms of the correlation between neutrality and diversity, these 2 average values require to be deconstructed into subgroup samples by spatial clustering. So we have segmented the gross diversity by 9 PET grades into the net diversity, denoted as a lowercase d% in finding 3. In finding 1, the diversity and PET maps in 3 seasons. A total 108 hours of daytime simulation for the 3 districts were carried out, including 15 hours for June solstice, 9 hours for December solstice, and 12 hours for September equinox. Here are the snapshots of these maps at noontime. And finding 2, we've compared the diurnal variation between PET in columns and the gross diversity in lines among 3 cities. We've noticed a slight contradiction in trend between them in summer, though sufficient diversity is maintained to provide freedom of choice, even under strong or extreme heat stress. In winter, the two marginally correlate. Thus, when cold cities provide less diversity, at equinox, there is the most chance to meet various stimuli preferences because they are synergistically trending with pet value. In finding 3, these synergistic and deviated results have also been confirmed by aggregating all the dataset on bubble charts to present the relationship between the net diversity and pet grades. A bifurcation of data occurs during hot seasons, especially in Vienna, where there is a polarization of high and low net diversity at high temperature, alongside a strong heat stress. The bifurcation patterns indicate increasing coexistence of the monotony and diversity of microclimate when pet value is higher. And the last 3 points for concluding these studies. We found a higher diversity in early afternoon in autumn and around dawn and twilight in summer. The net diversity is helpful to correlate neutrality and diversity. Finally, we've also found a positive correlation at equinox, negative ones in winter, and polarized results in summer. And here are some future research plans. We definitely need to validate the simulation results from this study. The diversity algorithms will demand a spatial dimension rather than purely numeric form. We would be interested in involving space syntax in thermal comfort studies. Last but not least, we also look forward to seeing the best theory to explain any causal effect between diversity, thermal perception, and spatial behavior. Thanks for listening.